So let me go ahead and record this one too. All right, so we're looking at example number 3 for linear programming, and the first thing you do is you determine whether it's a profit maximization or a cost minimization problem. And we have determined that it is a profit max problem. Okay, so how much profit do we make off of the anvils, the toy A? Wake up, guys. How much profit do we make off of toy A?
$2,
$2. And how much do we make off the balls?
$3.
There you go. Thank you very much. Appreciate it. Okay. So we're going to set those values to 0 right now because we don't know how many to sell. To find out our profit max, we're going to do the sum products. Of the coefficient and the value. Okay. So right now we're making $0. All right. Now let's take a look at each of the constraints. We probably won't have 6 for this problem, right? Okay. But the first one is the cost of each of the toys, right? So we have an 8 and a 14. So toy A, the anvils cost us $8 each, and the balls are $14 each, right? All right. We also know that we have no more than 2,000 toys will be sold each month, and we have $20,000 to invest in inventory. So however many anvils we buy times however many balls we buy has to be less than $2,000. So our first inequality is going to be about the amount of money that we have to spend on inventory. So we're going to put that in here, 20,000, and it's going to be equal to the total number that we buy for each one of them. Okay, so the cost is here. The amount of money we have to spend is here. Okay, let me just make all of those larger so you can see them. For my left-hand side, I'm going to take the cost and multiply it by the anvil, or the value for each one of them. Okay. Now, to make my life a little bit easier, I'm going to come here and I'm going to call this anvil, and I'm going to call this ball. And so all I have to do now is I'm going to say equal to the number of anvils, right? Excuse me, times the cost of the anvil, which we said was $8, right? Plus the number of balls times the cost of the ball, which is $14. Okay. What did I do wrong? Oh, I forgot this. All right. Now, why is this giving me a hard time?
Because
It
the
should
ball
just
isn't
be.
showing up the same as the anvil.
Oh, it's because I called this ball, not. That's why. Thank you. All right. So now that should be 0. Okay. So an anvil times 8 plus balls times 14 has to be less than or equal to 20,000 because I only have $20,000 to spend. Okay. The next one is relatively easy as well. The owner estimates that no more than 2,000 toys will be sold every month and does not plan to spend. So this one's going to be a less than or equal to as well. And it's going to be less than or equal to 2,000, right? And this is just going to be the anvils plus the balls equals spell anvil right, it might help, right? Okay.
Mm-hmm.
All right. So that has to be less than 2,000. And are there any other constraints that I need to take care of? So it looks like maybe there's a couple. Can anybody think of what they need to be? I'll give you a hint, right? So each variable needs to be non-negative. How do I account for that?
You say anvil not
Okay.
greater than or equal to 0.
Right. And that has to be greater than or equal to 0.
Mm-hmm.
And the
Ball greater than or equal to 0.
there you go. So you've got them all set up. So let's double check and make sure that we have accounted for everything. Okay. So we sell two types of toys, anvils and balls, right?
Mm-hmm.
Pays $8 for the anvil and $14 for the balls. Okay. Each unit of toy A yields a $2 profit. We've got that over here. Okay. And each unit of toy B, the balls, $3. The store owner estimates that no more than 2,000 will be sold, which we have. So anvils and balls together is less than or equal to 2,000. And the total amount of money that we're going to spend is less than 20,000. So the cost of the anvil, the number of anvils times the cost of the anvil, plus the number of balls times the cost of the ball has to be less than or equal to 20,000. And then so we have 0 for the non-negatives, and now we can begin our process. So let's go up to the data, solver, okay. And this time we're going to set again objective C. We're going to change the number that we sell, okay. And now, so I have to delete each one of these and start over. Right? So this is only because I had this left over from the last problem. So we're going to add another constraint, right? Left-hand side, less than or equal to the right-hand side. Add another one, okay? This is the left-hand side, less than or equal to the right-hand side. And this one, greater than or equal to 0. And add 0, okay? This, where did I get that from? D12 and D12, so we're good. All right, and so when you set it up correctly, this is what it should look like. All right. So then we're going to click solve, and it runs through the problem, right? And we'll notice here that we have values that are kind of funky, right? So we're going to keep the answers that we have. We click OK, and it gives us our reports. But we also know that we need to make these rounded to the nearest whole number, because you can't make 1/3 of an anvil or 2/3 of a ball. So we're going to simply round these to the nearest whole number. Okay. And these we'll leave alone. You got it? Although you can round those to the nearest whole number as well. Okay. It looks something like that. All right. So to maximize our profits here, we should make or sell 1,333 anvils and 667 balls, right? So it's a lot of anvils to sell. I don't think we're going to be able to do that, Andy. All right. So have we left any money on the table? And I can tell you the answer is going to be no, because we have spent all of our $20,000 and we have sold all of our toys. So let's go over and take a look at our answer report, right? And so our answer report shows us that our profit is maxed at 46.67, and then these are the final values for either one of them. Okay. We have a binding constraint on the amount of toys we can sell and a binding constraint on our money to invest, right? Now, one of the things we did not have is a constraint on our demand. So when you do your problem, you will have a constraint on that, so pay attention to that. For the sensitivity report, okay, we take a look and we see that our reduced cost is 0 for both. That means we're not leaving money on the table. And our shadow prices here, let's go ahead and make those dollars. The shadow prices here indicate that if we could sell more toys, that would be optimal. In other words, if demand was higher, then we could sell more toys, and therefore we would have a higher result. I'm going to come here and I'm going to double check myself and make sure that my final value actually does add up to 2,000, so that I know the final value of what I sell is going to be equal to the left-hand side of the equation. Okay. So putting all of these together as well, make it a little bit easier to read. If we could get more anvils, we'd be willing to pay 67 cents per anvil more if we could get them. So the marginal utility for the anvils is 67 cents. Okay, excuse me. The marginal utility for demand is 67 cents. So let me tell you how that works. If an advertiser were to come to you and say, I have the ability to sell you an advertising space, and I can guarantee you that I will get more customers coming in the door, and it'll only cost you 50 cents per customer. Would you take that deal, yes or no? He can guarantee you more sales, and it'll only cost you 50 cents per customer for more sales. Is that a good deal or not? Not everybody at once.
Yes.
Why is it a good deal, Anya? Because you're right. Tell me why it's a good deal.
Because the cost is low and you get more sales, meaning you don't know, well, we don't know exactly what they're buying. Well, I guess the ball and anvil, but in the long run, they're profiting more than what they're paying.
That's the answer, right? So to put it more succinctly, the cost of the customer is less than the shadow price, right? If he were to come to you and say it's going to cost you $1 per customer, you'd say no, right? Because the shadow price for more customers, which is what that first constraint is, right, is 67 cents. So you're willing to pay anything less than 67 cents, especially if you don't have to do any of the work. So let's say they're willing to build you a website and they say, look, for pennies on the dollar, well, tell me how much it's going to be for new customer acquisition, right? What if we had more money? So let's say, for instance, the banker comes to you and says, look, it's obvious to me that you need more inventory. And so if we could sell more, right, and we could do it for you for pennies on the dollar. As a matter of fact, for every dollar that you make extra, it's only going to cost you 20 cents. Is that a good deal or not?
No.
It is not a good deal, and that's correct, because it would cost you 20 cents for extra inventory, and it's only worth 17 cents to you. Good job on that one. All right, let's look at the limits reports. Not a lot of information here. This just tells you the limits to which those objective functions will still hold, right? It will hold as long as the number is somewhere between 0, right, and, or excuse me, $85 and $18,000. So That's a very wide span for this particular problem, so there's not a lot of information there. Okay, and so we've done that part. We did the limits report, we did the sensitivity report, and we did the answer report. Okay, so this is easy, right? Which of the constraints are binding? Right? So it's constraint 1 and constraint 2. And by the way, you can actually come over here and you can name these constraints so that when you run your report, you'd be fine. So let me say, for instance, this is my finance constraint, right? And then this one would be, actually, let me do that differently. So if I were to come here and say, this is my financial constraint, right? And then this next one is my market constraint, or the amount that I can sell. Okay. If I were to run this same problem again, all right, and I get the same reports now, right? No, I thought it would, but I guess not. I guess you have to change it after the fact. I think in the PC, when you change it, it changes the names for you too. No big deal. All right. Questions, comments, concerns? Right? We got this? Right? So how many of you feel confident that you understand this material and you can do a project on it? Okay. So George asked, what is the shadow price again? So let's come over here and take a look at that. The shadow price is your marginal utility, George. Shadow price is what you would be willing to pay for one more unit, right? So shadow price equals marginal utility. Okay. If we can get more of this resource, this is how much we would pay for it. Okay. Does that help? Okay. All right, any other questions on this? All right, sounds like we're pretty good then, right? So I'm gonna